session going. Yeah. Neha, can I get a confirmation that everybody can see the screen?
Yes, sir.
Thank you. So in today's webinar, we are going to be in the third part of the session. We're going to be talking about how we are actually dealing with consents, how we are actually exchanging health data in the NDHM architecture, and get into the FHIR formats that we use in NDHM. So on the agenda is first a demo and a discussion on these consent requests. And then we will do a demo and discussion on how to do health data transfer with the APIs. And finally, we will do a high level overview of the FHIR and NDHM FHIR profiles. This will be done by Manisha from the CDAC National Resource Center for eHealth Standards. Now, this is an interactive session like our previous session, so there'll be lots of opportunities to ask questions and get answers. So please use the raise hand feature, and we will first do the presentation and the discussion section, and followed by the queries at the end of each section. So we'll start as with every this one with a quick summary of the overview. So there may be a few of you who are new. We are uploading the YouTube links to the previous two webinars, and that should be there by the next couple of days. But as you know, NDHM has launched with the following 5 building blocks. And essentially, we are talking about how you can integrate your own application to act as either a health information provider or a health repository provider or as a HIU. At this point, we are still focusing our discussions primarily around the implementation as a health information provider and a health repository provider. And in the later sessions, we will talk about health information users as well as implementing health lockers. Now, in terms of the overall pieces, we talked about concepts, and I think most of you should be now familiar with these concepts, which is the concept of care context and the concept of linking. So in the NDHM architecture, the consent manager and the gateway itself does not have access to any health data. All health data is held by your software in which is deployed with associated hospitals, diagnostic centers, or labs. Any data that is exchanged using an FHIR based format or a standard that happens, and no data can move between the HIP HRP to a HIU without a concept called a consent. And the job of the consent manager in many ways is to simply maintain an index which says we are aware that this health information provider has certain health data, and we bucket health data into what we call as care context. And our advisory is that there should be one care context for each patient visit or each patient encounter. In the previous sessions, we have looked at what are the ways in which you can collect a health ID and actually save it in your system. So we talked about whether how facilities will need to issue health IDs, how do they collect and verify health IDs. And in the last session, we talked about implementing a HIP service. We specifically talked about making sure that you can have a discovery that happens and you can respond with care context, and how to actually link care context in the last session. So we will continue today's session with the second part, which is how do you get hold of consent requests and how do you respond to those consent requests with data in the FHIR format. And like I said, in future sessions, we'll also talk about how do you implement a HIU service as we go forward. So there is the guidelines apart from the documentation on the website. So I will request all of you to read the HIP HIU guidelines that you can find published on the Sandbox site. That shall also give you a guidance and overview of these various terms that we use in the NDHM architecture. To get this started going today, let's get started with consent notifications. Like we said, there is a consent artifact that is defined under the NDHM, and essentially whenever a HIU, and we saw using how the web HIU we can create a consent request for a user. And when the user grants the consent request, if you are implementing a HRP, you will be notified about this consent request, and you will need to save a copy of this consent request in your side when you're implementing HRP. And remember that you can get multiple consent request artifacts against which you can then provide the health data. So Sukrit, I'll stop sharing and hand it over to you to do a more detailed demonstration of this using APIs.
Yeah, sure. I'll just share my screen. Please let me know once it's visible. Is my screen visible?
Not yet, Sukrit.
Is it visible now?
It's coming.
Yeah,
Yeah.
right.
Okay. Okay. So let's get started with the consent notification and the data flow APIs. Now, before we go into the API demonstrations, just let's come to this bit, which part we are on the sandbox documentation. If we go to the building and HIP section. So last demo, we discussed about HIP initiated linking and the general linking. So now, please note that it doesn't matter whether the linking was a discovery and linking or a HIP initiated linking. Post that, the data flow remains the same in both cases. And also, data flow will always happen against an granted consent artifact. Okay. So what happens is, as soon as a consent artifact is granted, the HIP will be notified in this using this HIP/notify confirm. So now, as last time, I'll be using the webhook.site this to demonstrate the callback URLs that I get. This is already registered as an HIP, and I will be making the calls to gateway as HIP using Postman. And as and when we need to see things on the app, I will be using the Android emulator. Okay. So coming to the data transfer. So before the data transfer, as we mentioned here, the notification will be there on the consent with the consent artifact. And as an HIP, we need to respond to this with an on notify callback. Now let's have a look at how this consent notify request looks like. So I'll do it again. Okay, just for the information, I will do this flow again. But first, I want to walk through the flow because from while doing it from the app, there are time constraints within which this has to be done. So I'll just walk through once the flow and then do the actual demonstration. Okay. So coming back to the notification. If you see here, this is what a HIP notify/notify call looks like. It contains details of the consent artifact and all the relevant information. What the HIP needs to do right now is respond to this consent notification with an on notify callback. Okay. The API for the on notify callback, I'm just going there. Yeah. Sorry. I have it here. Sorry. So here we just need to respond with the consent ID, which was received here, the consent ID. And Post this, we will, and along with this, we also need to send the request ID as response.request ID, which comes here. Now, once the HIP successfully makes this call, the HIP will get the data push URL in the form of the health information request. So here, this contains a data push URL and some key material and a nonce. We'll talk about this in a while. Okay. Now, essentially, once the user receives, sorry, not the user, the HIP receives this notification or this data fetch data request, the HIP has to do two things. One, notify the gateway or like inform the gateway that it has received the data request. That happens in the on request callback. It's again similar to the on notify callback, where it is just against a transaction ID and a request ID. So here the transaction ID will go in here and the response.request ID goes in here. Okay. Now, this is just to inform the gateway. Once the HIP informs the gateway, then it needs to actually push the data. Let's see the flows once here. Here. So see, HIP gets a request, responds to it with an on request. Post this, it's the responsibility of the HIP to prepare the data and push it to the data push URL as received in the previous request. And again, after doing it, the HIPs will have to inform the gateway that it has successfully pushed the data, or if there are any errors, then also say that there were errors. Okay. Now coming to the preparing of the data bit. Okay. So the data is always transferred in encrypted format. All the detailed documentation is available here. The data is always a valid FHIR document. Okay. Now, what the HIP needs to do is identify what data needs to be transferred. How will the HIP identify what data needs to be transferred? If we see this request here, the notification call or even the data request call was always and is always against a consent artifact. So HIP would have received the request or the consent artifact as a part of the notification HIP/notify. You go down, this is the consent ID, and this is how it will know for which care context it needs to transfer the data. Okay. So then coming back to the preparing of the data, things to remember, it will be has to be a JSON and FHIR JSON, and it has to be in encrypted format. Now, how we encrypt and the data, it's here. So I'll just put up a quick write-up here to make this understanding a bit easy. See, so the data transfer is always happening between a receiver and a sender. So the receiver will request for the data and will get the data back. The sender will actually encrypt and share the data with the receiver. In our context, the receiver is always an HIU. The sender will always be an HIP. Okay. What the HIU needs to do is generate the public and a private key. This generation is based on all the algorithms and everything is specified here. It's the Phi-Hellman algorithm key exchange. So that's how it will generate a key. Okay, it will generate a nonce, which is nothing but a random key. Okay, and then it will call the data request API. And with the data request API, it sends a key and key, which is the public key as generated, and a nonce, which is the random key. So if we go back to the webhook response, if you see the request where the data push came, along with the data push URL, we saw these key materials, right? So using this, now it's the response. This is what the HIP has received. Now using this, the HIP needs to encrypt the data. But before encrypting, the HIP or the sender will have to generate a key pair using, then generate a nonce, the same thing. It needs to do an XOR of the receiver and the sender nonce, generate a shared key using the sender private key and the receiver's public key. Again, receiver is HIU, sender is HIP. Then encrypt the data using the XOR value and the shared key. And AES GCM still go. Okay. Now, once it encrypts the data, it needs to share the encrypted data, a key value, which in this case will be the sender or the HIP's public key that was generated, and again a sender's nonce or the random. Okay. Now this is how it will share it, and then again the HIU will have to decrypt and show the data. The process for decryption is quite similar. XOR of the random values, create a shared key using receiver's private key and sender's public key, and then decrypt the data. Okay. Now let's come to the app. So as I have stated earlier, the app in the backend in this case is behaving as an HIU. Okay. So when a user sees an data on the app, it is nothing but an HIU requesting for data against a consent. Okay. And now, okay. One last thing before I actually do hit the APIs is how do I get the encrypted data for the API call? So let's again go back here. So at the bottom of the page, we have the link to a Java and a C# example, which is just a example for a gist for Java to state how the encryption and decryption process works. So if you open one, it's just a simple example where we are essentially not doing much. We just encrypt some data and then we decrypt the data and we just print all the values. Okay. So I'm using this one here. So now I am the HIP. So what I need to do is basically from the request, I have to get the receiver's public key. From the request, I need to get the receiver's random or the nonce. Okay. Then this script contains the detail, but essentially it will do the XOR and encrypt the data. Okay. Then I will share this encrypted data using Postman. Okay. So let's now do the API demo quickly. Okay. So see, this is a linked care context that the user has. So as soon as I click on this get data, it will trigger the entire process. So on the backend, there will be a consent artifact against which data has to be transferred. Okay. So let's start the process, and I will try to do this a bit quickly, and we can discuss or I can explain in details later because there are time constraints here. So I click on get data, I go here, I get a notification here. Now I need to acknowledge this notification. Okay. I need to acknowledge this notification with the request ID as well. The request ID goes in the response.request ID. It's acknowledged. Yes, the correct values. It gets accepted. Okay. I think I might have used a wrong value. Okay, I sorry, my bad. I linked the context and everything for this one. See the data. I'll just do it again. I had to log in with a different user. Sorry, really sorry. So just clear the cache to avoid any.
Captain.
Yeah. So this has a linked care context. Similarly, so I'll go here and I'll try to acknowledge this notify with an HIP on notify call. Didn't get copied. As soon as I acknowledge, I get this health information request, which I again need to respond to with the on request. And requested. Now the time to the actual data transfer, and copy this nonce. And run my script. Okay. This is my encrypted data. Okay. So I'll go to my notification call. So not this data notification. So this is the data push URL, by the way. And add the content. Random sender other nonce. This has to be shared by me now. The sender's public key also. And the transaction ID again with against which I'm pushing the data. This has been accepted. It should now come up here if I see. I'm able to get the data here. Now, what is this data? It is nothing but the JSON format thing that I have encrypted and shared. Just for the reference, I'll show it quickly. Here is the, I just added the health data, and this is a valid FHIR JSON. Okay. This is just a valid FHIR JSON, and we will be talking about this in the later part of the session. Okay. And see, these informations are contained obviously within the JSON itself. So shall we, like, I know this, I had to go through this a bit fast. So let's stop now and ask questions, wait for questions. Or anyone, Kiran, do you want to add something here?
No, not at all. I think we can go to the question section. So we'll request people to raise their hands for any queries, and we'll have them ask. Was it? I hope the concept came across clearly. So right now we don't have any queries yet, or anybody at least who hasn't raised their hands.
So the API documentations are all available here, like all the different thing, and whatever I used in the Postman, it'll be present here. So since it's an HIP, all the gateway APIs are present here that the HIP needs to call. In this case, it had to call the on notify first, then on request, and after that, the actually pushing the data, which is not a gateway API, but a direct push to the HIU. Yeah. And one last step is there to close the entire process, which is once the data has been transferred, the HIP will also need to inform the gateway that the data has successfully been pushed. So that is the health information / notify API. Here.
Yeah.
So again,
so Sukrit, then that was asked. In fact, Manisha has been sent me a message on that question. Is what is the level of encryption used? Are we using a 256 bit or are we using a 128 bit? I think that is one question that we had. And Anshu, do you know the answer to this one?
AS256.
AS256. Okay. So Manisha, that's the confirmation that the encryption minimum is being used is 256, which is aligned with the EHR standards. So Chandak, please go ahead, ask your query.
Yeah, Sukrit, actually, I have one question related to after this data push URL. So after pushing the data, we have to notify to the gateway that I have pushed my record, right? And then if the notify will send a 202, that means that accepted, that means my data has been pushed successfully. Is it like that?
No. So what you are building an HIP, right?
Correct.
Yeah. So it's the job of the HIP to push the data to the HIU. Okay. And you will get the successor. So in this demonstration case, the HIU is the mobile app, because it is receiving the data. It is internally behaving as a mobile app as a HIU as well. Okay. So this is the data push URL. So once the data is pushed to the HIU will tell you whether it succeeded or not. So in our case, the standard is like we are using the status 202 for this. Okay. So once your HIU means once your HIP gets the success status here for this data, and you might be as an HIP, you might end up calling this API multiple times also because you have a lot of data. Okay. Yeah. So once you have pushed all the data, be it in one call or multiple call, what you need to do is inform the gateway that I have successfully pushed the data. So the transaction ID and the consent ID against which you have pushed, when you have pushed it, okay, and like status notification for each care context. Like, say in this case, if I have one care context, it will just be the care context for which we have pushed the data. That would be, say, this. Okay. So in case you would have got some error while pushing the data to the HIU, you need to mention that it was not transferred successfully. There was an error.
Okay. So you have seen my question in the dev forum, right? That actually I was doing some demo with this data push URL. So from the HIP side, I see that the data push URL has been called and I'm receiving that success data. So after that I have not notified the gateway that I have successfully pushed the data. So is it because of that reason that my data is not appearing on the PHR mobile app?
No, I think even that my guess is that would be because there are timeouts there, and if that's why I rushed through this demo. Okay,
Okay.
you have to acknowledge this as per the current settings. You need to respond to the uh, on request API. Okay, within a minute.
Okay.
So in this case, sorry, let's move down. So you need to respond to this within a minute, and on the app for it to come up, the app is currently waiting for 5 minutes to say that check whether the data has come up. So I'm guessing that is because of there were delays while doing it manually. If you do,
Mm-hmm. Correct. I'm doing it manually only. So might be that
yeah,
could be the reason. And is there
yes.
any way that I can understand that if there is any error on the gateway site or any error on the HIU, because I'm pushing the data for this NDHM PHR app, right? So
Hmm.
how do I get the log? So if anything, any failure happened there on the gateway site or maybe that on the PHR mobile app.
Yeah. So currently the logs are not available to be exposed, but I think it's in our pipeline and will be done in some point later.
Okay. Great, great.
Yeah, just to answer that on that, um, and just to complete this, that during the data flow, one part that Shukri didn't mention this was that as soon as the HIP is done with the transfer, it is supposed to tell the concern manager, I have transferred this data. At the same time, when the HIP receives the data, it will try to decrypt, it will try to do the processing, and in the process, if there is any error, for example, it conveys the same to the concern manager. If there is a success, it does the same. Now, the other leg part, as in like in case of an error, in case of a success, it probably doesn't need to do anything. But the other part, in case of an error, the concern manager will need to notify the HIP that for this transaction ID, you had sent this data and this was the error. So that loop, for example, needs to be closed. Right now, we don't have that.
Okay, thank you, Shukrit and Anshuman. I'll try to resolve this issue. I'll see and I'll post it on the forum. Thank you.
Okay. So I don't see any more queries for this section. Either we have lost our audience in terms of the concepts today, or hopefully the questions will come in later. Ria, you can go ahead.
Yes, so I had a query. So we are transferring the data in pages. So what can be the maximum size of a page? Like how much data can we send in a one page?
256 MB at one
Okay,
shot.
okay, thank you.
Again, like, and I would not advise you to send 256 MB. That is also quite a lot. But
Yeah,
yeah, chunk it out in terms of smaller page sizes.
okay, thank you.
Great. All right. So we are going to, since there are no more questions on this particular thing, we're going to skip to the, yeah, okay. I'm sorry. I think I have an Aman Verma who's raising hand.
Yes.
Aman
Yeah.
and Vineet. Yeah. Aman
Yes.
first.
Yes. So my question is regarding the chunking of data. So in the data push URL, the query context are sent in the form of list. Right? If there are multiple query contexts, we will be sending in them all together. Now, how are we supposed to do chunking when the data could be like in a list? They can be multiple query contexts that are sent.
So you imagine, like, remember that each of the data, anything that you send is sent as a bundle, all right, which is calling as the PHR envelope. That bundle, you're not going to compose one single bundle comprising of all the data. You are going to create multiple bundles. And in that case, you should, like, think about paging, right? Like, in terms of multiple pages. What matters at the atomic level that each entry you send it completely and a full. So consider, like, I don't think, like, a bundle should, like, exceed more than 256 MB. I mean, if it has, probably, like, there is something more to it. But yeah, so now you can send multiple, like, say, imagine, like, each of this is, like, say, 20 MBs or, like, say, 50 MB each bundle. You can chunk it and send it across multiple pages. There is no problem with that.
Thanks.
But
So,
the
yeah.
pagination is defined at the top level.
Sorry.
The pagination is defined at the top level, not at the care context level.
Right. For each entry, you are mentioning that this is the data for this care context, right? So you can send it as when you want, it doesn't matter. But as long as your each entry you have mentioned, this is the care context, and for this care context, this is the bundle that I have, it's all right.
Okay. Okay.
Vineet, please go ahead.
So as you demonstrated the flow of, like, when
Vineet, we can't hear you.
can you hear me now? Sukrit, can you hear me now?
No, so Vineet, we can't still hear you. So maybe you should try changing your.
You are not audible, Vinit.
Sukrit, can you stop screen sharing?
Kiran, can you hear me now?
Slightly better. Please go ahead.
Yeah, so for the data push URL, you demonstrated a sequence of encryption that algorithms need to follow. So as you said, in the API documentation, there is some examples for Java. For different languages, you have anything like for JavaScript or Node.js if you are using it on the backend. So what would be the sequence of flow for different languages? You can get the API documentation or examples of that.
I couldn't catch much of it. Anshu, could you?
I couldn't hear anything at all. It was very faint. Can you
Yeah,
type it out?
Vineet. Yeah, Vineet, can you type it out on chat? Ria, do you have another question?
No.
Okay, thanks. So Sumit, please go ahead.
Yeah, my question was regarding that pagination. Okay. So, do you have any sequence number maintained there? I'm sending different bundles, right? And different packets. So, sequence of the packets for reconstructing at the HIUN.
My data.
Am I audible?
Yeah.
So, I'm talking about, like, I'm sending different packets, right? In a packets, different chunks. So, is there any sequence to maintain there for reconstructing at the HIUN?
Anshuman?
It doesn't matter really, like, say you are sending 10 days of data, right? Like, so the expectation is not that, oh, you send, like, day one, day two, day three, like, sequentially as such. Yes, it will be useful. Probably, like, that's how you should send. But there is no, like, limitations that you should do it, like, exactly this way, right? As long as each of the entry you are sending the bundle that is complete in itself, you are allowed to. And how to arrange it, whether they show it in a reverse chronological way or they show it by month, whether they show it like based on the hospitals, that all depends on the HIU side. If you look into the PHR app, it just shows in a reverse chronological order by the date, but that depends on the the screen or the interface that one is using.
Oh, okay. So each of the packets should be logically self-contained.
Yes, absolutely.
So Vinny's question, Anshuman, is for the data push. We have we have a sequence of encryption and algos we use to prepare the data. So for different languages like JavaScript and Node.js, do we have documentation for these languages? And what will be the sequence of algos and encryption sequence? So generally, we are, of course, as you know, the overall architecture is language independent. We do have samples for some pieces in either Java or C hash that you will see on the sandbox. But we don't think there is anything in the architecture that will make it language specific. And of course, you're welcome to contribute to the community if you are one of the first to prepare something in a certain language and you want to contribute it to the community. I think you can publish it and please post it on the discussion forum on the dev forum. That will be useful to everyone. We're going to move. I think we are done with the section one for today's discussion. Before we move to the FHIR section, I'd like to invite Aryaman, who has an announcement on a upcoming hackathon, which will also use the sandbox. Go ahead, Aryaman.
Sure. Thank you. Thank you very much, Kiran. Not sure if I can be seen here, but it's okay because the main thing I'd like to share is this image. So, good afternoon, everyone. My name is Aryaman. I'm a volunteer with the iSpirit Foundation, and we've been working very closely with NHA, NDHM, other stakeholders to put together a hackathon around this exciting new infrastructure that's coming to the healthcare domain. So we call this event Healthathon 2020, and it begins on 24th October. It's a 4-week long virtual event, and during this event, we will have a hackathon in which teams will build upon the APIs and sandbox provided by NDHM. We will also have an ideathon, which is a competition for people who may not want to code but just contribute ideas and get feedback around the new businesses and products that can be created around these APIs, and a number of masterclasses and networking sessions and talks by people such as Kiran Mazumdar-Shaw, chairman of Biocon, the CEOs of Practo, 1MG, MFine, Apollo Hospitals, Medanta Hospitals, and several other stakeholders from the public sector, private sector, and medical community. So we are really excited for this event, and we believe that only when these three groups of stakeholders come together, that is public sector, private sector, and medical community, can we actually make the most of this amazing new infrastructure that Kiran and team are walking us through today. So that's why we would like to invite all of you to participate in this. It's a completely free event, and everything will be recorded and public, but you'll get the most out of it by actually signing up, because then we can tailor sessions around the audiences and get maximum participation. So some of our partners in this are the Swast Alliance, Matrix Partners India, Chime India, which is a group of the CIOs of all the various hospitals in the country, and HIMSS India chapter, which is a coalition of health information management systems. So regardless of which background you are from, if you are from public sector or government, if you are from a technology or corporate background, or if you work with some medical stakeholders like clinics or labs, please do go to this link over here. I'll post the link on the chat right now, and maybe we can even include it in a follow-up email. Please do visit this link, healthathon.devfolio.co, where there are more details about this event, how to sign up, how to participate. Last time we had a similar event for the fintech domain, and we had really great sort of speakers and folks who came in and shared their views. So you can see here some images of Mr. Nandan Nilekani, the head of Mr. Arvind Kapil, head of HDFC Retail Lending, the MD of Sybil, Kunal Shah of Cred, and several others. In the same vein, we are going to have lots of these leaders from around health tech, government, come in for this event. So please don't miss it. It'll be a great way to learn about this new infrastructure and get kickstarted on building it and including it in your own organizations. So thank you very much. That's everything from my side.
like to now invite Manisha from CDAC, who will take us through the work that we have done on FHIR and adopting FHIR for NDHM. So Manisha is part of the National Resource Center for e-health standards, and they collaborated very closely with the National Health Authority in coming up with the first set of profiles that we are using under NDHM. Manisha, please go ahead.
Thank you, Kiran. I hope I'm audible
Yeah, we can hear you.
and my screen is also visible.
Yes, it is now.
Thank you. So I'll just walk through about a little bit on the overview of FHIR and then the NDHM FHIR profiles, which are used for exchange of data in NDHM network. So just a quick overview of FHIR. I'm sure that many of the members here would know about FHIR, but just one quick recap. So FHIR is actually a health data exchange standard developed and nurtured by HL7 International. It's being called as uses an internet based approach because it supports all the latest technology, the REST API specification, XML, JSON, and RDF formats. It actually of resources that can be used in healthcare to exchange data and take care of the common use cases. So the resource themselves would be used, or they may be combined together to satisfy the use cases of exchange in healthcare. So it has around 145 resources categorized under different sections like entities, patient, provider, the clinical resources like your disorder, the diagnosis, procedure, and other kind of resources, and the financial types of resources like claims and others. So the specification also provides CRUD based operations where how do you use the REST paradigm, the get, post, and other kind of the APIs. It is extensible by design. It allows use case specific customization that I'll brief upon later. And it also has the terminology binding in the sense the binding with the clinical terminologies, coding systems that are also there at the relevant places. Okay, sorry, the screen was not moving. So a few highlights on FHIR. It supports human readable serialization format. We know we are working on the JSONs and other structures. It has the specification is free for you. The use, there are no restrictions for using. So one can refer the licensing part of the FHIR. Uh, and the other things that I have already discussed upon. So FHIR usage scenario, I'm just trying to give a different angle of usage scenario of FHIR than the general approaches. Those are being shown in various presentation where we say that we use it as an interface engine, we use it as a FHIR facade and persistent storage. Just another view to using FHIR. So FHIR specification we can use for sharing FHIR object itself, where there are one or more applications working through or interacting through a common API, but they're sharing FHIR objects. We could use FHIR for the exchange itself, as if the FHIR APIs, the REST APIs defined by FHIR are used for interaction and communication between the application, and of course the FHIR object is used for exchange. And the last and the ultimate, where the FHIR objects are being stored in database, exchanged using FHIR APIs, and the object used are the FHIR objects. So we are going to look at the first scenario where FHIR objects is shared across a common API. Yeah. So this is an overview of the FHIR resources. If you go to hl7.org/FHIR, under the resource list, you will find this list of resources. The numbers at the right hand side corner of each resource shows their maturity level. So the 0 being the lowest maturity, and n means the normative. It's being defined and complete in the all aspects for data exchange and communication. So the resources are actually unit of exchange of data that are used for sharing between the health systems. They are known with a unique identifier. We call it as canonical URLs, which can be used to address them, refer them. The resource combine both computer processable and human understandable data. Those include the metadata, uh, which are used for searching or cataloging or identifying a resource, the structural specification, the content itself, the value sets used within the resources, for what should be the values included in a certain codified element. The display element, which are the simplified text, can be used for display on the on any screens on the browsers, and the links to the other resources. That is what overall a resource content. The example would be the patient, practitioner, or all other kinds of resources. Somehow screen is not running smoothly. Yeah, so if you could see, these are the different parts of resources, where the first part, if you see, there is ID, and the meta part, which are the resource identifier and the metadata part. It has nothing to do with health data, but it is required for identifying a FHIR resource altogether, and few of them are mandatory. Then you could see there are the text element coming in, which is a human readable text that is provided. One can have elaborated human readable text for the resources, where people can read them across, or even without having any application to process the underlying structure. And then there's something called extension, that I would talk about it later, but extensions are something you add on to the existing FHIR resources for your need, and that comes here. And then the ultimate structure. So for example, in here in the patient resource, you could see there is name, telecom, and other things coming in the code, where the what is the type of the resource it is. Okay. Yeah. So these are the overview of the data types available in FHIR. So there are the range of primitive data type and the general purpose data type. If you know the HL7 V2 and 3 kind of structures, you would know that there are something called composite data type in HL7 V2X, and those are represented here as general purpose data types, where the primitive data types are combined for a logical structure. So for example, you have codable concept, you have the quantity as one data type, address as one data type, which is reused at many places and being prepared as a logical entity. And there are some metadata types, and then some special purpose data types like references. Okay. So coming on to the bundle, uh, so bundle is something which where you want to use more than one resource to combine and make a logical structure for sharing data. So what in FHIR, what you can do is you can share individual resource also from a FHIR server to a FHIR client. Uh, but when you want to send all of these multiple resources into a one single transaction for some logical purpose, you can bundle them. For example, something called lab report, where you will have the information about patient, the organization, practitioner, the order information, and ultimately the observations in that lab report. That all can be bundled together. So bundle itself used as a as the name. These are few available reference implementations of FHIR, which are free and open source, can be referred, which would aid the implementation. So coming on to the profiles and extension. So when we say the FHIR resources, those resources uh, are made to make them useful for any general purpose use cases. For any specific use cases, you can use those resource, constrain them. So constrain them for making them required for your purpose, fixing some value sets for the coded element. You may want to add a new data element to the existing resource, or a new data type when called as an extension. So this such a definition or such modification to existing resources are called as profiles. So FHIR profiles describe actually a set of rules that should be used to meet any specific use case or a general use case, uh, so that the rules are shared and published between two systems, and they become the basis for implementation, so that both system knows that if I'm going to get a patient resource, the patient name, uh, for example a family name, is required element in it, and I have to support serialization of that particular element. So in original original patient resource, you will have it optional, but in FHIR profiles you can make it required. So this is how the profiling works. So they define, you can define constraints on the core data type, on core resources, and any other existing profiles of FHIR also. So everything all is called profiling. And the important part is, when you create profiles, then they require a formal published definitions to be available for implementers to refer. So why we need profile? A small example, the FHIR can be used for multiple and diverse context, as I said, and the same concept can be represented in different systems using different components and attributes. So just an example, the patient resource itself, I can put it a required or mandatory elements of the existing resource for my specific purpose. And each implementation in that case can be a subset of the existing FHIR specification in terms of its capability, content, and the format, and even the transport mechanisms. And that's why we need profiles. So profiles actually, I already spoke about the requirement of profile, and this profile actually helps you to put up the conformance on the content and the data, and the operations that are being performed. So profiling actually helps defines the required or optional resource elements. They define the additional resource element that may be needed, helps you to do the binding of terminology and the value sets that are being used, and also give an insight on deciding which API features that you may want to use or may be allowed, and then how. So I'll brief upon now the FHIR profiles for NDHM data exchange specification 1.0. So in NDHM, what is being decided is the 4 core clinical artifacts would be considered uh, for supporting continuity of care scenario. These 4 artifacts were diagnostic report record, discharge summary, outpatient consult note, and then the prescription. So the aim was to cover most of the health record document sharing in any care setting in India. So that was the aim, and these are the initial artifacts being decided upon. So to cover these 4 artifacts, 28 FHIR profiles, the core profiles, have been modeled, and which include four of these clinical artifacts and the 4 core profiles. And we have also provided certain value sets for standard clinical terminology to support their use case in profiles. I'll go about detail in the, yeah. So what is IG? An implementation guide is actually a set of rule about how this FHIR resources are used to solve a particular problem, and provide the documentation associated with it, and clarify the usage. So it actually defines the scope, it describes the requirements for implementation, it also provides the structured access to the profiles and the examples, and the guide for NDHM is hosted here on this link. Yeah. So before we go on reading guide and understanding and trying to read profile, few important things that to be noted. The text summary for on each of the profile shows the human readable summary of the changes that are done in the existing profile. It refers to differential view. What differential view is, it actually mentions which elements are changed while profiling to the existing core resource. Okay. And there is something called mandatory element. You may have seen the cardinality 1 across different elements. So this cardinality says that in FHIR core there would be certain elements which have the cardinality 1 they have to be derived. You cannot change the existing cardinality, the mandatory elements of the core specification, but you can add on within your profile. And this cardinality states that this element is mandatory while sending data, while sharing the data. So the cardinality 1 so that data could be something called the metadata, for example, your resource ID or any other information, and few elements which are required as per the FHIR specification. And when you do profiling, you may also add certain elements to be mandatory while sharing data within your own, say for example, in NDHM network, we want that, certain information is mandatory for sharing. So at that place, we will have the cardinality as 1 and then there is something called S, which shows that this is a must support element. So what does must support means is that the implementations that produce or consume resource shall provide support for these elements in some meaningful ways. So in NDHM, must support would be the HIUs, who are the receivers, must have the capacity to read this element, although it might be optional or required. Okay, although it might be optional, but if it is a must support, then HIUs must have the capacity to read this element, while the HIPs may opt not to fill this element while sending. When this would be the particular case when there is no data available for sharing. But if it is mandatory and must support, then if the mandatory cardinality would take over. So you have to support that element. So let's try and look into the IG. Okay. So if you could see here, the implementation guide, there is a brief overview, and then how to read this guide section is also provided. And we will just walk through the clinical artifacts here. See the 4 clinical artifacts provided here. I'll just try to check on the OP consult record. So this is the differential view that I was referring to, and this is the text summary that I was referring to. It says that the 8 elements, there are 8 mandatory elements, there are 39 must support elements, and then 33 elements which are having the fixed value. And the here it says that these are the structures which are referred within this element. So when I am sharing an outpatient consultation note, I need to have something called patient resource, encounter resource, organization, condition, observation, allergy intolerance, family member history, and the other.
Manisha? Hello, sorry
Yeah.
to interrupt you, but we are not able to view your screen, the IG browser.
Okay. 1 second. I'll just try to. Thank you for telling me that. Yeah, I would share the full screen now. Is it visible?
Yes, it is now. Yes.
Yeah. Thank you,
Can you
Sally.
start it again
So
from the home page so we will be able to see?
I'll do that. So we were here. Uh, this is the FHIR implementation guide for NDHM, which is referring to the data interchange specification 1.0. This guide gives you the preliminary background here on the home page and the section where it says how to read this guide. This section would help you to navigate, and these are the 4 clinical artifacts that I was referring to in the presentation and the resources which are referred under these clinical artifacts. To start with, I'll just go through the OP consult note here, and if you could see, this is the text summary section where it says that you have some mandatory element, you have some must support element in this record, and there are some fixed value element, and this particular resource refers to this many all other FHIR core resources or other resources, you could say that. That includes all this set here. And this is something called differential view. This view will help you to understand what changes have been done to the existing profile. So, so if, for example, for this outpatient consult node, this is profiled on the composition resource from FHIR core specification, and there are so many changes into the core composition resource. You could say that the status is stated as must support. So although it is mandatory existing by the FHIR core profile, but the HIU who is receiving entity should also have the ability to store this data, capture this data, or process this data. Here, if you see the bold 1 shows that this element has been made mandatory. Whatever is being highlighted in differential view would be the changes. So, for example, here the subject is mandated. And you could see the fixed value also put in, because this is an outpatient consultation note. This nomad fixed value, the code and the value have been put here, which says it's a clinical consultation report. This is how you need to read each and every profile. The full view will tell you everything about the composition resource. Additionally, the changes done by the current profile. The composition resource is being named with the changes done as an outpatient consultation note. So I'll just go through one specific existing FHIR resource, which is encounter, if you see. And here again in differential view, you would see that these changes have been done for use in NDHM. So in NDHM, we say that the code, if the coding is coming, although not mandatory, but it should be supported by the receiving system because sender may send it. And if a code element has been sent, then code is minimum required and the value is also required. Okay, and the code should come from this binding, which is the terminology binding. And if we just try and check what all types of encounters are possible, so if it is referring to the existing encounters of existing value sets defined by HL7, then those have not been touched upon. But if there are any new bindings that have been introduced, for example, here if you see in diagnosis, we say that what is the use of this diagnosis, then the codes have been defined here, and it is being binding is put as the preferred, so that as much as possible when you send a diagnosis and the condition and the use of diagnosis, with currently it is not mandated, but when you share it and a coding is provided, then the binding is nomicity, and the binding use here states that it should have all the elements coming from nomicity from this all the descendants of this concept, which is the qualifier for type of diagnosis, and the list is being provided here. So whether this is a preliminary diagnosis, whether it is an working diagnosis, a final diagnosis while used in discharge, or any other. So the type of diagnosis to be coming from nomicity, and not any code can be added. You have to bind it to this all the descendants of this concept only. So you can't have the diagnosis use coded with any procedure or something like that. SNOMED City has around 17 hierarchies, and there are multiple codes coming from different hierarchies. The binding has to be done from the relevant hierarchy. So if you click on the profile, you will see all the list of profile and read those profile accordingly. And what we have done is with each profile, we have given the sample examples to those. So when you want to check the examples, you could see them here. So for example, there was one query, how do we share DICOM images? So I'll show you the example of bundle, which is a diagnostic report imaging, where you could see this narrative is coming from the div text stack. And if you check the JSON object here, um, you could see there would be the DICOM file associated under the imaging study. So yeah, it should be there somewhere. Okay, and the links would be provided. So this is how you need to read the IG itself. And this four clinical artifacts are the bundle type of artifacts, have been are the artifacts coming from the composition and to be sent using the document bundle, which is again modeled specifically for NDHM on the R4. So you could see a bundle resource where we say that the securities must support, meta information has to be included, version related information should be there, the identifier information should also be there, and timestamp is also required. And you use this bundle for sharing any of these four artifacts that we have discussed upon. And the example for all of these artifacts is provided here in a bundle resource. So this would be the bundle diagnostic report lab, for example. So these kind of bundles would be the bundles of the exchange in NDHM. So the information on even on the packaging is provided here, just to give a few links, and it is being said that the main envelope would be the bundle. Okay, so this main envelope here is referred as this bundle, where the differential view says describes what all changes have been done, and the full view provides every detail about the bundle, where you can add the signature and other information also. Yeah.
Manisha, could you cover a bit about what are the open source libraries and validators that are available
Sure, I can
for
do that.
working
So
with these data?
yes, so I will put a few implementations over here. So there are a lot of open source available, even validators, even implementation. You have HappyFire APIs, the HappyFire server client, and the validations implementers. Even HL7 itself provides its own Fire validator. All of this information are available here on the link. Fire downloads. There are implementations available. There is something called Cleanifire. There are so many validators already available, which can be directly used for validating. We have done all the verification validation towards most of the commonly used validator. And yeah, that's it. So I think I have covered from my side.
Thank you. Sure. Yeah. Thanks so much, Manisha. We'll open up the session to any questions. And I think while Manisha's had a coverage, I would like to just share a bit about the philosophy that we used when we were actually making these NDHM FHIR bundles. Our intent is to help implementers start, if required, with something very simple, which is like in any of these formats. If you look at, we are allowing an attachment to be something that can be shared. So all you will need to do is to create a simple FHIR envelope or a overall bundle, and you can put an inline PDF or an image attachment as part of the report. So this is possible for everything from diagnostic reports to discharge summaries to prescriptions, any kind of a format you can always do. But this is not really where we want to start. While we know that this is quite easy for a lot of implementers to kind of start with that. Ideally, we would like you to go towards more and more structured data. But we understand that implementing structured data would also mean that in your own software, first you would need to make sure that when the data is being created or captured, you're able to adopt either Loin codes or SNOMED CT in your own systems. There are going to be specific efforts that NHA is going to work along with CDAC and several others, for example, to make it easier for people who are doing lab systems to adopt Loin code. So we have had some discussions and we are going to start an initiative where that's going to happen. CDAC has already done quite a bit to make it quite easy to implement or support SNOMED CT within your own implementations. So you can go to the same NRCES site and you can start off there, and if required, you can also post those queries onto the discussion forum on how you can adopt or get access to SNOMED CT for implementing in your own software, and between NHA and NRCES, we'll be happy to kind of have that shared. So with that, we'll kind of open the thing for
Thank you,
questions.
Kiran. I missed on that point. So just to show if this is a diagnostic report, this is a diagnostic report record where you could see the composition can have all the data, and here the entry part where it should come under the entries, and maximum 2 is possible, where it says that the diagnostic lab report can come, which could be from the laboratory or from the imaging side, or otherwise you could just put up a document reference as an attachment. So any one of them could come, and both of them can also be possible. So you can either add a structured diagnostic lab report or an imaging report, or add the structured one with the document reference, or include only document reference. So all of them is possible.
Yeah. So we'll start with Einar Vetrivel.
Yes. You had mentioned that FHIR supports CRUD operations. I have a question regarding updates. Are all the fields in a FHIR resource updatable, or are there any specific guidelines which says that only some fields in a FHIR resources are updatable while others are not? Or is it that all the fields are updatable?
Yeah. So, Einar, actually, the way we are using FHIR is that we don't use the FHIR's REST API architecture at all. So, if you saw Manisha's presentation, there was a section where she talked about how we are using FHIR objects for the interchange, but we don't use REST APIs or the CRUD construct that FHIR has at all within the NDHM architecture. The main reason being that NDHM is focused on a consent-based data sharing approach between somebody who's creating the data like a HIP and a HRP to somebody who's consuming the data like a HIU. And that is not a construct that's available in the FHIR REST API layer. So we do not use the REST API layer. So in the FHIR part, the primary area that is adopted is the resources and the resource structures.
Yes, but to answer your question, if there is something called the FHIR specification again for the REST API. So when you say what CRUD operations are supported, you are referring to a FHIR server, right? So there you have to put up the specification. You have to state that what is allowed, what is not allowed, what all operations are possible, which all elements are possible. Say for example, even for searching, for updating, for adding, for querying, for the get operation, you can specify that.
Okay, got it. And so if any of the field in a resource is updated, then we'll have to maintain a duplicate to show that what was incrementally updated between two versions of the resource.
Yes, the resource version would change. So there is field which talks about the version of the resource.
Yeah.
Which is mandated here. Yeah. in
Got it.
NDHM specification.
Yeah, got it. Thank you.
Any other queries?
Hi, can you hear me?
Yeah.
Yes.
Hey, hi. Most of my queries have been resolved or answered. I have one specific question over here. So again, when we come to the rural landscape, major problem is that having too much of structured data captured from the users becomes much more difficult, right? Uh, and user will not be able to provide that. But slowly to be able to capture the meaningful information from the users and make it consumable across the platforms, it will be a big challenge for any startup that is trying to understand the healthcare ecosystem. So in this process, FHIR looks, very elaborative. So at the minimum, to go ahead and facilitate the data exchange, uh, can you please help the companies to, through the documentation where we can say that, hey, look, these are the minimum supported, though the kind of current documentation says that these are required, these are must, these are mandatory, and these are the defaults. Three sections have been, it has been divided into three sections. But for people like us who are into complete rural space, don't have too much of data, right? So we'll be very much confused what to send, what not to send.
Can you give
Right?
me an
How to tackle
example?
this?
Yeah, can
Yes,
you give me an
Saida.
example of which type of document are you trying to, for example, do you have in your system?
So currently it's a custom format, right? Most of the companies, I believe, most of the startups that have
I
been bootstrapped in
understand.
last
Underlying. No, I'm talking about, are we talking about a diagnostic report? Are we talking about a discharge
all
summary?
four
What kind
types,
of, huh?
all
You have
major.
all, okay. Yeah, I
So
think, go ahead, Manisha.
yes, Saida. So, what I was talking about is the must support and the mandatory element. So, if you see the current specifications, the
Okay.
current profiles also, the approach that was used by NDHM itself was to have the minimalistic approach and try to put only the elements which are logical and minimally required for the care continuity as the must support or the mandatory element. And
Okay.
if you just go look at the profile, very few are there which are required and which are the must support kind of the element. And even when you are sending, the required elements are the ones which you have to focus more, and must support are something which will give you which will give the logical meaning to that record being shared. So if you see only these two elements, they are very less number, and you
Okay.
should be able to create a very meaningful record out of them.
Okay.
So the
Great.
example shown on the profiles have like most of the things populated for all implementers to understand. But if you see, if you try to create a record which has only the mandatory and the must support element, it will be very small one.
I think what we will do, we'll take that feedback, Saida, and we will publish some of these, the most minimal format for each of these formats also on the sandbox documentation as an example, so that people can see what is the mere, only the required fields for any of these four formats. I'm sure that will be
Yeah,
useful to you.
as we excel together and progress together, we'll be able to add the complexity to the system. But to get started with, yes, companies needs the hand holding at the beginning to make sure that we don't lag anywhere.
Sure. Thank
All
you.
right.
I think
Thank
we'll do
you.
that. Any other queries?
Yeah, so I had a question. So essentially, I just wanted to understand from the perspective of, like, say, in our organization, we already have a PHR set. We already have an EMR inbuilt, which uses Nomad and lawing standards. So, how do we transfer or if we are to interoperate with NDHM, how do we take that transition from whatever we already have or the schema we already have and put it into an FHIR based structure?
So you have the clinical terminologies already integrated, which is already like you have done some work where you can quickly onboard onto the FHIR
No,
profiles. So,
So for
that is
example,
actually a plus for you.
no, so for example, right now we have fields like diagnosis, medication, patient profile, and all of that, but we define it according to our own terms. But like for each of these diagnosis or lab investigations, we have integrations with Loink and Snowmet already in place. So what would be the steps to essentially then, if you are to like interoperate, do we need to pass it according to the schema defined for NDHM FHIR, and then start, like if you are to get data from an external source, how do we do that migration, or how do we like transition the data from what we already have to a FHIR based profile?
Yeah, so you will have to, if you it is about the architecture of your application and the further plan. So you could do by simply creating some map where you can get your fields mapped with the FHIR fields, and then create the resources based on the schema, and then share it, and while receiving do the reverse process. So that would be the simplest and easiest approach.
Okay, sure.
Again, it depends on how is your application architecture and what is the further plan.
Yeah, so you can post if you have a specific query. Again, you can post it on a discussion forum, and we can have one of our experts look at it and get back to you, Ranak.
Sure.
But like Nisha said, if you are already in a very good position, if much of your underlying data is already terminology coded, if diagnosis is terminology coded, or if a lab report is already terminology coded, it becomes very easy for you to create a FHIR bundle in a NDHM format when you're doing the data exchange.
Okay.
So one of the queries asked on the chat was, what about other document formats? Do we only have to work with these 4 formats, which is the OP consultation, prescription, discharge summary, and diagnostic report, which have been decided? That is, for now, we are starting with these. We are keen to actually understand what are the other type of data formats that we should be standardizing under NDHM. We are aware, for example, from public health programs, we are looking at immunization records for sure as one of them. So please let us know, drop us either an email or put on the discussion forums as to what are the other types of data that you are planning to share, and we would be happy to make sure that we can provide a approach to having those standardized quickly under the NDHM program. Anybody else who has anything to add? Yeah. Manisha, you're saying?
There are few hands there.
No, I think
If
they've all
anybody has
older
question.
hands asked their questions already. So I think, yeah. With that, folks, I think we can bring today's webinar to a close. The YouTube links for the previous 2 sessions are done. They were posted on the group. We are also going to post it on Sandbox documentation/webinars. Also, all the collections that, the Postman collections that Sukrit was showing from the last session as well as this session also will post on the Sandbox piece. I'm happy to see that there has been quite an active participation in the dev forums. Request you all to continue to use the dev forums to ask your queries so that the overall community can also benefit if they're searching or looking for similar problems and answers. In the next webinar, we are going to focus on implementing a HIU, and that will be the key webinar, and we'll see whether we can also add what are the certification, security, and exit criteria that will be part of the NDHM program, and we'll try to bring this webinar series to an end. With that, I think we would have covered most of the elements. We will have to do one more on the health locker. So we'll have 2 more webinars, one focusing on HIU and security, and the last one on health lockers. Thank you, everyone. Thanks for the participation.
Thank you.
Thank you. Bye.
Thank you.
Thanks.
Bye.
Thanks. Bye.
Thanks, Atan. Yeah.
Hi, thanks.